Example 4. Find the critical points of f of x equals this absolute value of x. So if we go ahead and just graph this, we can see visually that the derivative does not exist right here. So we can just say critical point at x equals 0. Now, if you feel like that's not satisfactory or it seems a little bit too hand-wavy, we're just drawing a picture, there is a way for you to actually at least in the sort of spirit of what we did here, try to go ahead and do this. We could calculate the derivative of this function, because really a absolute value is really just negative x if x is less than 0, right? If x is negative 2, then negative 2 is positive 2. So basically, we're taking the opposite of x whenever x is negative, thus it makes it positive. And then we just make x stay the same if x is not negative. So if we take the derivative of this, what we end up getting here is it's negative 1 if x is less than 0, and it's positive 1 if x is, now you got to be careful, this inequality doesn't actually stay or equal to, it becomes strictly greater than, because the slope, the left-hand slope here is negative 1, the right-hand slope here is positive 1, but at x equals 0, the left-hand slope being negative 1, the right-hand slope being 1, they're not equal, which means the derivative doesn't exist, which means you cannot include x equals 0 here. The derivative doesn't exist for x equals 0, so you can only talk about the derivative for values of x other than 0. So in this case here, by the very definition here of the derivative, you see that x equals 0 isn't in the domain of the derivative, which is the definition of a function not being differentiable at a location. What is the domain of the derivative? Is it all values of x, or is it excluding some values of x? So that's something else you can think about.